move forward. So what did we learn in the last lecture? Not very difficult, but all of this area sometimes is a brain teasing. You need to be very careful. First of all, basic concept, the difference between latch and register. Anyone want to explain to me what is the difference between the latch and register?
Latch is the label sensitive and the register is edge sensitive. Thank
you very much. Yes, so exactly, right? So for latch, it's like when, for example, this is a positive latch in this case, right? Or a transparent high, right? So this is transparent high. So when the clock is high, right, then we will copy the data, and you still see that when it is high, the data are copied to the queue, right? When this is high, the data is copied to the queue, and you copy right away as long as it is high. So when this go from 1 to 0, it just copy to the outside, to the output, right? For this one, we say this is a positive edge trigger register, right? So as what she said, right? You only copy when the clock go from low to high. Okay, so here you see that when this go from low to high, it is copy. When this go to low to high, it is copy, right? So when the data becomes 0, because there's no edge trigger, so it has no action until here. When it has edge trigger, then it is copy. So that is difference between latch and register. Not too difficult, but don't make mistake, because sometimes I still see students make the mistake. For this fundamental thing, leave no room for mistake. Okay. Now, then how? And then for in particular for edge trigger register, we have 3 very important quantity. We call it the setup time, hold time, and T to Q. Right? What is setup time? Anyway, from here you see that when the clock goes up, we are going to copy the data, right? So when does the data needs to be ready? When the clock goes up, we request that the data to be stable for T setup time. Okay, this is a requirement. Why is that? Depends on particular circuit, but this is a general thing. Okay, you need to be ready before I copy. And the same, after I copy, do not change it yet. You need to hold it for T hold. Otherwise, I cannot copy. Why is that? We will, in some circuit, we will see why later, right? It can be 0, it can be non-zero, right? So, but anyway, as a good circuit designer, you need to know what are the T setup and T hold. And then when the clock goes up, it also take T to Q, the amount of time to copy it to the output, right? So do not expect to have the data before TCQ, I mean C to Q, right? So that is the important thing about this rule that we need to follow. Any questions? Now, if no, here just show an implementation of a latch, right? Based on this, can someone tell me whether this is a positive latch or negative latch, or transparent high or transparent low? So during the clock, what is the clock signal going to copy the data to the output? So this is like a multiplexer, right? So just now someone went to my office hours, asked about multiplexer, but not really, but that we mentioned, talk about multiplexer. But what we said is, I was thinking to my heart, this is a circuit that you can try. You can try also. Okay, now I forgot. If I said in the handout that you need to use CMOS, or you are allowed to use the transmission gate. So let me don't mention it. So anyway, so when the clock is high, this transistor is on. This is NMOS and this is the PMOS, right? So this is also on, right? Because clock bar is off, and now this one is off. This is off, right? So then the data will go through. So this is transparent high, right? Okay, so this is a way that we can implement the latch. Of course, we talk about a few issues, including too many gates to drive, so it will be slow. And then we propose maybe just use a pass gate, but pass gate has its own issue, right? The only issue is that if you use NMOS pass gates, it cannot deliver what type of voltage? Well, NMOS is good for deliver 0 or 1. Do you remember? NMOS is good for passing 0 or 1.
0.
0. Very good. Yeah. But then you have problem in passing 1. Okay. So all this issue, and then we talk about long overlapping. Okay. So once we have this multiplexer, right? This is a transparent high. So basically, this is talking about this one. Right? This is transparent high. Then we combine two of them. We have a transparent low. We call it master latch. Right? And then this is high. Another is slave, right? So this is a master slave pair. And what it will give me? It gives me a positive edge trigger register. This was the last thing I talked about in the last lecture, right? So let's review again how it works. So when the clock is high, okay, let me start with clock is low, right? When the clock is low, which one is transparent? This one is transparent, right? And this is cut off, right? When the clock is low. And for the slave, this is on and this is cut off, right? So what happened during this time? The D is copied to DM, to QM, right? This is a copy action, right? It keep copying, it keep changing, it keep copying. But for Q, nothing happened, right? Because this is off, right? Nothing will go out. That's why nothing happened to Q. So as a whole circuit, I feel that when the clock is low, it's not affecting the Q. Now, when the clock goes up, right? When it goes up, what happened? Now, this one will be on and this one will be off. This one will be off and this one will be on. Then at this time, the data cannot be copied to Q anymore. So you see that here, no copying, cannot, right? But the Q, which was copied right before the clock goes up, will be copied to the Q, QM to Q, right? Then overall, your feeling is that, okay, before the clock goes up, D is not affecting Q. Right after clock goes up, D is copied to Q, and then we cannot change it anymore. That's why it's positive edge trigger. Okay, any questions? Is that clear? Now, if it is clear, then now we want to see how we implement it. It is not too difficult. What I'm doing is just expand the transparent low and transparent high latch, right? Remember here again, I have a multiplexer, which is the latch, transparent low and transparent high, and I put it here. This is just exactly what we are doing, right? And then for the clock, you see that I need to have an inverter to bring this in, right? So this will be clock bar, right? So when the clock is low, then it will be passing the stuff just like here. Now you cannot see it. This is 0, right? When it is 0, it's passable. Okay. So this one you go back to read carefully yourself, but now continue on this circuit. I want to talk about the timing. What is the setup time for this clock? What is the setup time? What is TSU? Again, what is the meaning of TSU? TSU means that my data need to be ready before how much time how much time my data need to be ready before the clock goes up. When the clock goes up, it means it will copy the data from Q from here to here. Right? Here is when clock goes from 0 to 1, it copy to output. Is this okay? Right? The clock, like you do many things, no matter what, when the clock goes up from 0 to 1, this one is on, this is off, then it copy, right? So if I want to copy as a whole circuit D to Q, D has to be ready. When it has to be ready here, right? Then of course, when I copy, I want the D to be ready here already, right? Right? So the D has to reach I4, right? When the clock goes up, then I can copy, right? How much time does it take for the D to reach I4? That was before the clock goes up. So at that time, the clock was at 0. So T1 is on, right? And then you go through I3 and go to I4. So you see that the T setup time is equals to Ti1 plus T1 plus Ti3 plus Ti4. Okay, and I put here already I1, this inverter, I call it PD inverter. So I have free inverter is free TPD inverter plus TPD transistor. That is the setup time. Is that clear? Try to understand now. If it's not clear to you, let's discuss, right? Because you're sure you will see something like this in the final. Although for other circuits. Any questions? Right, so let me summarize again. We think in the circuit in this way. When the clock goes up, we copy the data from this point to this point. Once it copy, then we are done, right? But then in order to have the valid data at this point, it means before my clock goes up, this data need to propagate to here already. That means that before the delay of this path, my data need to be valid. You cannot still give me junk at that time. You need to be ready so many nanoseconds before my clock goes up. That's the T setup time. How about the hold time? Can someone tell me how long the D has to hold? Right? For example, I try to copy 1, right? The 1 propagate all the way to here, and then the clock comes up, I copy. Once the clock goes up, do I need to hold this at 1 for some longer time so I can copy successfully? Do I need to hold it? Any idea? Who think that the T hold is larger than 0? Please raise your hand. No one who think that we don't need to hold it. No one. So what's your question? Or no one is listening. Okay, I have one person. Okay. Okay, thank you. Anyway, this COVID online really bad for teaching. So yeah, so we don't need to hold them, right? Because once I copy, remember what happened to T1 at this time when it becomes high? Because T1 is off after the clock goes up, right? Because the clock is 1. So after that, no matter what you change in D, you're not going to affect me. I already store the value I want to copy. So T whole equal to 0. Okay. How about TCQ? How much time once I copy, right? Once the clock goes up, how much time does it take for the data to appear at Q?
T3 and I6.
Thank you. Very straightforward. You just need T3 plus TI6, which is equal to TPD inverter plus TPD TX, right? Now, so I'm done, right? That's what I can teach you, right? And can you use this, apply the same knowledge to the in the exam, right? And if you have a question, let me know. I do need you to spend time. I realize that now I realize that it's not a good time to teach this class in the spring because many students are graduating, so they don't care. They just want to get the grade and then quit and then leave, right? Which is valid, but I actually pretty, not about you guys, but I know some, right? Actually did not really study. They just maybe have someone to help them understand and then disseminates the knowledge to them. But this is not a good practice, I can tell you. The way I teach this class is like, I hope you go through the lecture and I keep repeating something important. And I hope you get it. It's not about going back and then memorize the textbook one more time. Okay. Yeah, so this is the setup time, hold time, and clock to Q. Okay. Now, then let's just quickly